Hi, welcome to this video. In this video, I'm explaining about the double Atwood machine. This is a two body, two pulley system. So in this case, we have to find the acceleration of the given masses. So let's get started. First of all, let's write down the forces acting on the its masses. Let's say T1 be the string, T1 be the tension in the upper string, and T2 in the low string. Since T1 tension is produced by none other than the T2 forces, T2 tensions of the below string, so we have T1 equals to 2 times T2 relation, as I have written down here. And I have considered the upward upward forces as positive and the downward forces as negative, and so so if we write down the equation of motion of these three masses, it becomes as this. I hope it is quite clear. Just taking for mass m1, T1 is in the positive direction, is accelerating in the upward direction. For M3, it's accelerating downwards, so taken minus, and T2 is tension is acting in the upward direction, gravity is downward direction. So based on that, I have written these things. Okay, so here we have three relation for four variable, one tension and three acceleration. So we need one more relation. We get that from the relation between the acceleration of these masses. So we have this relation in this case of pulley system. So using this four relation, we can find the acceleration. So if we solve these four equations, we get acceleration values as this. I would also like to derive the relation of this acceleration, which is quite interesting. Also easy. Okay, let's do it. So I forget to mention that I have considered relation between the masses to be m3 greater than m2 greater than m1. So m1 mass is less than the mass sum of the m2 and m3, obviously. So m1 will move upward direction. By the same distance, the pulley will move downward. And in the case of m2 and m3, if the m2 will move upward direction, m3 will move downward direction. But if we think the scenario when the whole pulley is not whole second down, the pulley down, whole pulley is not moving, then the distance m2 moves upward, m3 will move the same distance downward. So actually it is the conservation of the length of the string. So I have write down the how pulley how the distance of these masses get changes at the very beginning of the uh, start of the motion. But let's try derive the relation at for general. Let's suppose for the time dt, the mass m1 moves up by dx1 distance in the upward direction. From here, I'm using the distance covered by body in upward direction as positive and negative in the downward direction. So since m1 moves by dx1 distance in the upward direction, m2 and m3 move downward direction by dx1 and both by dx1 distance. So I have written it as minus dx1 to show the downward direction. So we can think of it as like the second pulley system whole moves dx1 distance, and by the difference in the masses of m2 and m3, they also move certain distance up or down depending on their masses respective to each other. So from after m2 and m3 move dx1 distance downward, m2 will, let's suppose that m2 will move d1 distance upward direction. Then by the conservation of length of the string, m3 mass will move by same distance d1 dy but in the downward direction. So from here on, let's see the net movement of m2 and m3. So to show the relation between the acceleration of m1, m2, m3 masses, so the net movement, let's see just the sum of the downward movement and upward movement. So like dy was the upward movement, so positive, dx1 was the downward movement, so negative, and for second mass both distance are downward, so we get this relation. And from these two equation of m2 and m3, by equating the values of dy, we get this equation, and from this equation we get the values of dx1 as follows. And so since we imagine the above scenario for the very for a small instant of time dt, so equivalently we can say their corresponding velocities relations is as follows. And by differentiating by dt in the both sides, we get this required equation. So we have derived the relation between the acceleration. And yeah, so in this video we explained how we can solve the acceleration of masses into pulley system. Thank you for watching the video. Yeah, see you in the next video.